geobyte.
Similarly, look at the another important problem asking like this. A system is taken from state A to state C by two paths A, B, C. One path is from A, B, C. Other path is right action figure. The interlange at A is interlange at A, UA given 10 joules. Along the path ADC, along the okay, there are two paths. One path is ADC, one path is ADC, other path is ABC. Right? For path, let me write it clearly. For path, for path ADC, the second path for path ABC. Okay. Now for path ADC, along the path ADC, the amount of heat absorbed, that means heat supplied for ADC given 50 joules and work obtained, work done by the system for that path, W for ADC given 20 joules. Whereas along the path ABC, heat absorbed, heat for A BC, ABC, it is given 36 joules. The amount of work along the path ABC, work for ABC is how much? That is the question. For that, first let us take the path ADC. For path ADC, I can write QADC equal to WADC plus UC minus UA. Since interlange is the property of the system, property does not depend on the intermediate state D. Therefore, UC minus UA equal to QADC minus WADC. Look at the QADC 50, WADC 50, 20. 50 minus 20. 50 minus 20 is equal to 30 joules. Okay. Similarly, let us take the for path ABC. For this path, I can write that Q for ABC equal to W for ABC plus UC minus UA. Once the initial state and final states are same, irrespective of the path following, interlange change remaining same because interlange is coming under property of the system. Okay, then you are asked to decide WABC. WABC equal to what? Q for ABC minus UC minus UA. What is the Q for ABC given? Q for ABC given 36. 36 minus UC minus UA found 30 is equal to 6 joules. Okay, answer is 6 joules. Look at the option D. Option D is absolutely correct. Understood clearly? Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Which of the following relations does not give the equation of adiabatic process where terms have their usual meaning? Okay, as you know, reversible, reversible adiabatic law is, or simply adiabatic law is PV power gamma equal to constant. Okay, since PV power gamma equal to constant is adiabatic law, PV equal to constant is not coming under adiabatic law. That is the isothermal law. Okay. Now it can be also written as P1 V1 power gamma equal to P2 V2 power gamma. Now I am going to find relation between the temperature and pressure and temperature and volume for the reversible adiabatic process. From this I can also write P1 by P2 equal to V2 by V1 power gamma. But as you know, ideal gas equation is P1 V1 by T1 equal to P2 V2 by T2. From this, I can write that V2 by V1 equal to P2 by T1 into P1 by P2. So in the place of V2 by V1, I am going to write T2 by T1 into P1 by P2 power gamma. Can also be written as P1 by P2 is equal to T2 by T1 power gamma into P1 by P2 power gamma. Okay. It can be also written as P1 by P2. You bring the P1 by P2 power gamma to left side. That is becoming 1 by 1 minus gamma equal to T2 by T1 power gamma. Let us take another slide. Here you got P1 by P2 power 1 minus gamma equal to T2 by T1 power gamma, or P1 power 1 minus gamma by P2 power 1 minus gamma equal to T2 power gamma by T1 power gamma, or P1 power 1 minus gamma into T1 power gamma equal to T2 power gamma into P2 power 1 minus gamma. Let me write orderly. P1 power 1 minus gamma, T1 power gamma equal to P2 power 1 minus gamma, T2 power gamma. So from this I can write that P power 1 minus gamma, P power gamma equal to constant. This is also adiabatic relation in terms of pressure and temperature. P power 1 minus gamma into T power gamma. Look at the option A. P power 1 minus gamma, T power gamma. This is the adiabatic law. Adiabatic equation in terms of pressure and temperature. Similarly, let us decide for relation between the temperature and volume. Okay, for that, as you know, so here you got P1 by P2 power 1 minus gamma equal to T2 by T1 power gamma. But what is the P1 by P2 in terms of volume? So from this P1 by P2, look at the P1 by P2, look at the P1 by P2 equal to V2 by V1 power gamma. So in the place of V1 by V2, I can write V2 by V1 power. Okay, 1 minute. This is the 1 minute. P1 by this is 1 minute. This is the T2. T2. Okay. So okay. In the place of P1 by P2, in the place of P1 by V2, you can write V2 by V1 power gamma. V2 by V1 power gamma. Whole power whole power 1 minus gamma equal to T2 by T1 power gamma. So this gamma is cancelled. This gamma is cancelled. Finally, what we got here, V2 by V1 power 1 minus gamma equal to T2 by T1. Right? Otherwise, I can also write V1 by V2 power gamma minus 1 is equal to T2 by T1. T2 by T1. That can be written as T1 into V1 power gamma minus 1 equal to T2 into V2 power gamma minus 1. Therefore, T into V power gamma minus 1 is also constant. This is also adiabatic expression in terms of temperature and volume. T V power gamma minus 1 equal constant. T V power gamma minus 1 equal constant. This is also adiabatic equation. Adiabatic equation. Look at the option D. It is P just T power 1 minus gamma. No, already you got relation between the pressure and temperature. P power 1 minus gamma, T power gamma equal constant. So it is also not adiabatic expression. So option B and option D are not coming under adiabatic expressions. Understood? Or adiabatic equations. I hope all of you clearly understood. Understood or not? Yes. Then let us take the another important problem. Oh, completed. All the problems what we what I have prepared. thermodynamics completed. I hope all of you clearly understood. Understood or not? Yes. Thank you. Thank you for watching. Okay. Yes.
Geobyte.